All right, so we're going to take a look at one that requires a little bit more work in factoring the numerator and denominator. But again, we're finding points of discontinuity through factoring to identify. That's why that's step 0. So we're going to go ahead and take a look at the denominator. We're going to factor that using the magic X technique. So negative 54 will be the top number, 1 times negative 54, A times C. And then on the bottom, we get negative 3, our B value. So we're going to figure out our magic numbers are negative 9 and positive 6. And negative 9 times 6 will get you the negative 54, and you add them, you get negative 3. So because the A value is 1, we can go ahead and factor using my magic numbers, which are x minus 9 and x plus 6. Pretty good so far? So then we have now successfully gotten to the place where we can identify point of discontinuity, which are going to be x equals 9 and negative 6. And that happens from setting the denominator equal to 0 and figuring out what would cause that to be 0. So those are my points of discontinuity. The domain for this function is all real numbers, comma, x can't be those two things, 9 and negative 6. But the point is to figure out my x-intercepts. And the x-intercepts will come now through reducing. Reducing has to require I'm in factored form for my numerator. So I look at the numerator and perform step 2, which is to recognize they have a GCF of x. So if I factor out an x, I'm going to be left with 3x minus 1. So that my job is to look at the reduced version of this, which is x times 3x minus 1 over x minus 9, x plus 6. So all that work is to get to the place where we can reduce. This particular function has nothing to reduce. The top and the bottom have no like binomial products, no products that are the same, no like terms. And so I now press through. I'm not actually going to analyze both of those are vertical asymptotes, but that's not the point for my points of discontinuity. The point is now, whatever's up top, which is everything, you set that equal to 0, just the top, and solve. So I had to do the work for the bottom just to identify what can't be an answer for my x-intercepts. So now what I do is I take this x times 3x minus 1 equal to 0 and solve using the zero product property. The zero product property with this x out in front, you would set that equal to 0, and it's solved. One answer is 0, one x-intercept. A second one, 3x minus 1 equals 0. You solve by adding 1 to the other side, and then you get 3x equals 1, and you get a result of x equals 1/3 after dividing 3 from both sides. So I have an x-intercept at 0 and 1/3, and our job is to write those as coordinates. 0, 0 is one answer. That comes from this one. And then my second answer would be 1/3, 0. 0 here being the y height whenever you have an x-intercept. So 1/3, y height of 0.